at Embedded World. We're in Hall 1 now on the Renesas stand. Robert, good to meet you. Renesas winning combinations. I find them fascinating because Renesas has amalgamated so many companies with different specialties, and you've brought them all together in these winning combinations to help us all make designs. Can you walk us through a couple of them, please?
Yes, so this is a very good example of winning combinations shown here on the wall. This device is basically showing all the products that we have, from battery management over DC-DC, over lithium-ion charger, over the wireless charging part, which goes on here, as you can see on this pad, and going to the microcontroller with BLE, and the sensors from X-Interseal.
That's really small to have so much. That's really small to have that much on it.
Yes. The nice thing about this is it comes with everything. If a customer wants to redo this, we have Gerbers, we have PCB layout for it. We also have the casing with the recommendation what plastic to use, because the TVOCs that are being measured should not come from the plastic but from the environment. And we also have the app, as you can see on the screen.
Yep.
Currently the air here is pretty bad, so we have 1.9 milligrams per cubic meter TVOCs in the air,
right.
And the overall air quality is low. Temperature is 25 degrees and 37% humidity.
That's why it feels a little bit clammy in here.
It is, yeah, exactly.
You've also got a light sensor on there. How does that work?
Well, there's this little baby here is a light sensor.
Wow, that's tiny.
And it's basically taking in the light from around here.
Yep.
If we cover it up, you're going to see it's going to go down to very low, which is here.
There you go. Wow, that's perfect. That's
Okay.
amazing. So what else have we got here?
On top here we have the general boards from Renesas for engineering kits from the RA family.
Right.
The nice thing is all the engineering kits are identical on the top part.
Right.
So they are reusable. If you have decided to go for an RA6 and you want to go to an RA4 later, you know that on the EK boards the top is going to be the same. Why is this so? We have P-mode interfaces which are common to these boards. We have the Arduino interface, we have the microbus on there, and everything else. On the middle part we have the specifics of your microcontroller.
Right.
The RA6 and 5 come with a wired Ethernet, so we have the wired Ethernet on there. It also comes with the quad SPI and octa SPI, so we have flash devices on there which have these interfaces. And this device also has a high-speed internet, USB, so we have the USB output on there. So as a user, as a customer, you don't need to make your PCB first to start getting off the ground. You can do your design immediately from there.
Just easy almost to plug and play.
But this is not from SSD, this is not a winning combination.
Right.
The winning combination comes what we have connected here.
Okay.
So here we have pluggable, the Wi-Fi, Bluetooth, or Wi-Fi and Bluetooth module.
Right.
Because here we have the P-mode with serial port. On this side we have the I2C. Here we have again the same sensors as we have there, air quality, temperature and humidity. The nice thing about this is we have in the meantime an ecosystem of boards which can fit on the side, and they are pluggable, they are daisy chainable.
That's amazing.
Because they go all on different addresses on the I2C, and we have the software for it in the FSP for RA family. They come with a library. If you want to design, you say, I want to have this device with this communications on this microcontroller. With the FSP, you have the capability of making everything in one go.
So it makes it really, really easy for designers to choose what they need to get those sections and then just stick them together.
Or they go to a different microcontroller because the performance that they had originally chosen is too much or not enough, and then they can go to a different family.
That's really good. Now down here we've got the green pack. So Dialogue is a recent acquisition for Renesas. I find the green pack quite fascinating, and I know there's been an awful lot of interest in it. Can you tell me what you've got showing here?
The green pack demonstrator here is basically the HV green pack, which is going up to 12 volts.
Okay.
The next family is going to go up to 26 volts. The demonstrator here is basically a PWM controller
Right.
that can do stepper motor control, light control, right button, or basically here a DC motor control,
Right.
where you do everything from the HV controller.
Okay.
This device specifically is very nice because it can be corrected. On runtime you can also modify the settings or what you want to do with it by changing it via I2C.
Okay. And what about the section underneath it? What does that do?
That's the programmer board. So we have here the Zero Force connector,
Yeah.
and with this board you can simulate your green pack before even programming anything with it.
So you just pop your chip in that board, in that little
Yes.
environment, and you can just work it in situ.
And you can then program it to put it on your PCB.
Wow, that's amazing. Thank you very much for taking me through those.
You're welcome.